This is a comparison of orbital launch systems. The following exposes the full list of conventional orbital launch systems. For the short simple list of conventional launcher families, see Comparison of orbital launchers families. Spacecraft propulsion is any method used to accelerate spacecraft and artificial satellites. A conventional solid rocket or a conventional solid fuel rocket is a rocket with a motor that uses solid propellants. Orbital launch systems are rockets and other systems capable of placing payloads into or beyond Earth orbit. All current spacecraft use conventional chemical rockets for launch, though some have used air-breathing engines on their first stage. Legend for orbit abbreviations in table. Legend for launch system status and below table. Under development Euro, retired Euro, operational, proposed in design concepts. Non-rocket launch. See also, comparison of orbital launchers families, comparison of orbital rocket engines, comparison of space station cargo vehicles. Notes, there are many different methods. Each method has drawbacks and advantages, and spacecraft propulsion is an active area of research. However, most spacecraft today are propelled by forcing a gas from the black rear of the vehicle at very high speed through a supersonic de Laval nozzle. This sort of engine is called a rocket engine. The first medieval rockets were solid fuel rockets powered by gunpowder. They were used by the Chinese, Indians, Mongols and Arabs in warfare as early as the 13th century. Such as the Pegasus rocket and Spaceship One. Most satellites have simple reliable chemical thrusters or resistor-jet rockets for orbital station keeping and some use momentum wheels for attitude control. Soviet bloc satellites have used electric propulsion for decades, and newer Western geo-orbiting spacecraft are starting to use them for north-south station keeping and orbit raising. Interplanetary vehicles mostly use chemical rockets as well, although a few have used ion thrusters and Hall effect thrusters to great success. A full listing of the Ariane 5 launch history is in its main article. Suborbital test in 1969, first orbital launch attempt in 1970, ABCDEFGHIJKL with 9.5-foot fairing, without Buran, and assuming payload providing orbital insertion, AB. The U.S. Space Shuttle Transportation System and the Soviet Enaja Buran system, consist of launch vehicle rockets and returnable spaceplane orbiter. Payload values listed here are for the mass of the payload in cargo bay of the spaceplanes, excluding the mass of the spaceplanes themselves. The SpaceX website lists the F-9 payload to LEO as 13,150 kilograms. The payload to GTO is listed as 4,850 kilograms. However, SpaceX has stated that these numbers include a 30% margin to accommodate reusability. Not including two launches made using the HESSB and HIS configurations, only launch failed to achieve orbit. Suborbital test flights in 1995, 1997 and 2002, no orbital launches attempted. The N-1 rocket was initially designed for 75 mt LEO capacity and launch attempts were made with this version, but there were studies to increase the payload capacity to 95 mt, if a liquid hydrogen upper stage engine could be developed. The Saturn V made 13 launches, 12 of which reached the correct orbits, and the other reached a different orbit than the one which had been planned. However, some mission objectives could still be completed. NASA, Saturn V News Reference, Appendix, Saturn V Flight History. For more information, see the Saturn V article. The Saturn V launch record is usually quoted as having never failed, for example. The rocket was masterminded by Werner von Braun and did not fail in any of its flights, Alan Lowry and Robert Godwin. Saturn, but the Apollo 6 launch should be considered a partial mission failure. The 13th launch of Saturn V was in special configuration with the Skylab. Suborbital test flight in 2004, first orbital launch in 2006, a third rocket exploded before launch, first orbital launch attempt in 2005, AB operated by land launch, operated by sea launch, references.